Hi, welcome to my channel. In this video, we want to solve the following problem. Given sin A over sin B equals sin C over sin D equals sin of A minus C over sin of B minus D, where A, B, C, and D lie strictly between 0 and pi. We want to prove that A equals B and C equals D. And now for the solution. First, suppose A equals C. Then sin of A minus C equals sin 0, which is 0. Since sin A over sin B equals sin of A minus C over sin of B minus D, we have sin A over sin B equals 0, which implies that sin A equals 0. Therefore, A equals n times pi, where n is an integer. But this is impossible, since A lies strictly between 0 and pi. Therefore, A does not equal C. So let us suppose that A is greater than C. The discussion for the case when C is greater than A is similar. Since A, B, C, and D lie strictly between 0 and pi, sin A, sin B, and sin of A minus C are all positive. Since sin A over sin B equals sin of A minus C over sin of B minus D, after rearranging, we have sin of B minus D equals sin of A minus C times sin B over sin A. All the terms in the right hand side is positive. Therefore, sin of B minus D is positive. This implies B minus D is positive, or B is greater than D. Next, let's define a triangle PQR such that angle P equals pi minus A, angle Q equals C, and angle R equals A minus C. Note that the sum of the angles equals pi minus A plus C plus A minus C, which is pi. So PQR is a valid triangle. A possible diagram for the triangle is this. Following this, we define another triangle XYZ such that angle X equals pi minus B, angle Y equals D, and angle Z equals B minus D. Again, the sum of the angles equals pi minus B plus D plus B minus D, which is pi. So XYZ is also a valid triangle. A possible diagram for the triangle is this. Next, consider the equation sin A over sin B equals sin C over sin D, which can be rearranged to obtain sin A over sin C equals sin B over sin D. To proceed, we shall use the law of sines. Given a triangle with interior angles A, B, and C, and sides opposite these angles denoted as small letter A, small letter B, and small letter C respectively, then the law of sines tells us that sin A over small letter A equals sin B over small letter B equals sin C over small letter C. Applying the law of sines to triangle PQR, for angles P and Q, we have sin of pi minus A over QR equals sin C over PR. Sin of pi minus A equals sin pi times cosine A minus cosine pi times sin A. Since sin pi equals 0 and cosine pi equals minus 1, sin of pi minus A equals sin A. Thus we have sin A over QR equals sin C over PR, or after rearranging, sin A over sin C equals QR over PR. Applying the law of sines to triangle XYZ, for angles X and Y, we get sin of pi minus B over YZ equals sin D over XZ. Since sin of pi minus B equals sin B, this simplifies to sin B over YZ equals sin D over XZ, or sin B over sin D equals YZ over XZ. From sine A over sine C equals sine B over sine D, we have QR over PR equals YZ over XZ, and thus QR over YZ equals PR over XZ. Next, consider the equation sine C over sine D equals sine of A minus C over sine of B minus D, which can be rearranged to obtain sine C over sine of A minus C equals sine D over sine of B minus D. Applying the law of sines to triangle PQR, for angles Q and R, we get sine C over PR equals sine of A minus C over PQ. Rearranging, we get sine C over sine of A minus C equals PR over PQ. Applying the law of sines to triangle XYZ, for angles Y and Z, we get sine D over XZ equals sine of B minus D over XY, or sine D over sine of B minus D equals XZ over XY. From sine C over sine of A minus C equals sine D over sine of B minus D, we have PR over PQ equals XZ over XY, and thus PR over XZ equals PQ over XY. From our earlier result of QR over YZ equals PR over XZ, we thus have QR over YZ equals PR over XZ equals PQ over XY. QR over YZ is the ratio of the corresponding sides QR and YZ in triangles PQR and XYZ. PR over XZ is the ratio of the corresponding sides PR and XZ in triangles PQR and XYZ. PQ over XY is the ratio of the corresponding sides PQ and XY in triangles PQR and XYZ. The equal ratios thus imply that triangles PQR and XYZ are similar. Since angles P and X are corresponding angles in similar triangles, we have pi minus A equals pi minus B, and thus A equals B. Similarly, since angles Q and Y are corresponding angles in similar triangles, we have C equals D. Therefore, we have shown that A equals B and C equals D, completing the proof. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.